In this video, we're going to learn how to use a transistor as an electronic switch. Before transistors were invented, electric circuits were controlled using mechanical switches. Mechanical switch physically opens or closes a path through a circuit. A transistor can perform a similar operation, but instead of moving a piece of metal with your hand, we controlled the transistor using a small electrical signal. Mechanical electric circuit. We have a battery, a brass switch, and a light bulb. Brass conducts electricity. When the switch is open, there's a gap in the circuit. The current cannot flow through the complete circuit, so the light bulb is off. When we close the switch, the circuit becomes complete. Complete means the current can flow from the positive end of the battery all the way through the components, in this case the light bulb, back to the ground. That's the complete circuit. The light bulb, back to the negative terminal of the battery. The light bulb comes on because there is now a complete loop through which current can flow. Let us look briefly at two ways switches can be connected. The first arrangement is called a series circuit. Here, two switches are connected one after the other. For current to reach the bulb, it must pass through both switches. If the first switch is closed, but the second switch is open, the circuit is still broken. Light comes on only when the first switch and the second switch are both closed. This is why two switches connected in series behave like the logical operation AND. This idea will become important when we begin to build logic gates from transistors. Okay, here's switches wired in parallel. Parallel means there's two wires. Each one's got a switch on its own wire. So obviously if one is open, another one's closed, the electricity can still flow through to the bulb because there's two paths. Each wire provides another possible path for the current. If the upper switch is closed, current can flow through the upper branch and the light comes on. If the lower switch is closed, current can flow through the lower branch and the light also comes on. If both switches are closed, current has two available paths and the light remains on. The light is off only when both switches are open. This is the same in logic as the logical operation OR. This one or that one. The transistor. Now we're going to replace the mechanical switch with an NPN transistor. There are other kinds of transistors which we'll talk about in other videos. Okay, this transistor has three wires or terminals, three that you plug into the Arduino. They are the collector, the base, and the emitter. The collector is marked with the letter C. The base is marked with the letter B. The emitter is marked with the letter E. It's important to know that different transistor models can have these pins arranged in different orders. The letters are small and hard to read. If you get it backwards, your circuit won't work, so look at the transistor closely to see the letters. In the transistor shown here, the terminals are labeled collector, base, and emitter from left to right. Okay, transistors are also semiconductors. Okay, these are insulators when turned off and conductors when turned on. That's the definition of a semiconductor. Okay, this is how a transistor acts as a switch. In this circuit, the emitter is connected to the ground. That's the one on the right. The collector is connected to the circuit containing the lead. It's the one on the left. The base, the one in the middle, is connected to an Arduino pin through a resistor. The base controls whether the transistor is on or off. When the Arduino sends a small current into the base, the transistor turns on. This allows current to flow through the collector to emitter path. Transistor then behaves like a closed switch, but a closed switch with a switch with no moving parts. Okay. Then the LED circuit is completed. The current flows through to ground via the collector and the emitter, and the light lights. When the Arduino output is off, the transistor blocks the flow of electricity and the LED remains off. Now let's look at how the circuit is connected. I'm using Tinkercad instead of the actual Arduino board because it's easier to see on the screen. If you try to wire this up with, if I try to wire it on a table with a camera pointing down, it's hard to see the numbers and it's hard to see everything. And also the Tinkercad lets us try out our designs before we commit to putting them on the Arduino card. A complicated circuit on the Arduino card, it's kind of difficult to stick the wires in. I use a magnifying glass myself. But anyway, the Tinkercad, you can see the Arduino and the breadboard and the labels of the components. Plus you can run it in the browser and write the C code there too. So it's useful for testing a circuit before you plug it into the Arduino. First we connect the Arduino's 5-volt pin to the positive rail of the breadboard. Then we connect one of the Arduino ground pins to the ground rail of the breadboard. The positive rail supplies 5 volts to the circuit. The ground provides the path back to the Arduino. Now we place the NPN transistor on the breadboard. In Tinkercad, we can move the pointer over the transistor legs, and then a little window pops up to identify the collector, base, and emitter. Makes it easy to use. The emitter will eventually connect to the ground. The collector will connect to the LED branch. The base will connect through a resistor to Arduino pin, turning the transistor on and off. Okay, next we place the LED on the breadboard. The LED has an anode and a cathode. The anode is just the positive side of the leg. It's the longer leg. On the physical LED, it's longer. That's how you identify it. The cathode is the negative side. It's normally the shorter leg. Also, the plastic body of the LED has a flat edge on the cathode side. Okay, the LED is connected with a 220 ohm resistor. That keeps it from burning out, right? You need to have a resistor in front of it, or behind it actually, anywhere along the circuit. The positive LED branch connects to the resistor. The other side connects to the transistor's collector. Now we connect the emitter. We connect the emitter to the ground rail to complete the circuit. When the transistor turns on, current flows through the LED branch into the collector, through the transistor, and out of the emitter to the ground. That completes the circuit. Okay, we also need to connect a 1 kilo ohm resistor to the transistor's base to protect that component. The other end of the resistor connects to the digital pin 12 on the Arduino. We can pick any pin as long as it agrees with the number that we use in the C code to turn it on. Okay, so you can run simulation to run your C code. We say digital write high, power goes to the base, the transistor turns on. So the code is the switch. Now notice that you could wire circuits without any code at all. Like your house is wired, for example, using the positive and negative rails and skipping the numbered pins. But that would be hard coding the circuit. You don't build a programmable device that way. Code is very simple. We have the basic setup. We define the global variable switch as a constant. Give it the value 12. In the setup loop, we just say that's the one we're going to use, basically. Then in the the loop itself, it runs continually. So here we say digital write, switch high, turn the transistor on. We could put in here a timer delay and say digital write, switch low to turn it off. Then you could make a blinking light.